Good morning and welcome to our next presentation. Today, as you can see, we're going to be looking at Inventor Cam, so our machining environment inside of Inventor. And without further ado, there is a lot that we're going to unpack today, so I'm going to go through it quite quickly. But if there's anything in particular that I think needs some further explanation, we'll slow down a bit and have a look at a few things in there. And yeah, without any further ado, let's get straight into Inventor. So I'm busy looking at that camera. I should be looking at that camera. So awesome. We've got our main setup over here inside of Inventor. I've just straight into a part. So this is obviously once we've taken our part, modeled it inside of the design environment, we then go over into a Cam tab where we've got different tools available to us from inside there. So as you can see, we're in our designing environment. If we wanted to, we could use our 3D modeling from inside here. Essentially, we're going to go look through 3 different parts and how we would machine them using Cam. So if I start off with this 2D adaptive part over here, you can see that we've got a fixture modeled already. So if you want to add your fixtures in, just so you can analyze how your machining is going to go around those. We've also got the ability inside of the Cam environment to add fixtures for collision detection. So this is possible. And as you can see, we're inside the normal environment where we could do our 3D modeling. This is a live part. We could make changes to this live within Inventor. To get to this, to the Cam environment, you would need Inventor Cam installed. And once you've got that installed, it is an add-in and has its own tab available to you. So we've now got an Inventor Cam tab that is available to us. With the within the Inventor Cam tab, we're mostly going to be working from left to right. So we've got the ability to start off with our setup. We want to be able to create a setup. And the setup will essentially drive all of the settings for this entire operation. So inside of the setup, if we just select setup from inside here, you'll see I've already got one configured. So I'm just going to activate this one very quickly just by double clicking it inside of the browser. You can see we've got all the different settings that we can drive from inside of the setup manager. So the first thing we can choose in the setup tab is a machine. If you are using a specific machine, you will want to choose this from the get-go. And this will essentially, by choosing that one, take you to Inventor's machine library, where we can come and choose whether we're using a milling machine, a turning machine, or a cutting machine. And we've got various standard machines that we can choose from, named Autodesk, as well as a few other vendors that we can choose from as well. So if you've got a machine that you've pre-configured, we can come in and set that up inside here. Otherwise, we can edit the machine library and add our own machine in so that Inventor knows the machine configuration. And this will essentially be driving a post processor towards the end when we want to post this out. Depending on the machine we choose and the configuration we choose, it will automatically pick up the post that we want to use to create our G code. You don't have to choose a machine if you don't want to, so we can leave this out if we wanted to. In this case, I'm just going to choose a generic 3-axis machine from Autodesk and OK that from there, and you'll see that that's now added in there. For the other configurations, I'm going to leave it blank so you can just to show you that you can leave them empty, and it will still take us through the entire process from there. The next section down is the operation type that we're using. We've got the abilities from here to pick whether we're using milling, whether we're using mill turn, so any turning functionality, whether it's just turning or whether it's turning with a live tool. We've got mill turning as well. And we've also got cutting, as you saw earlier, based on the different machines. It would automatically pick up the operation type based on the machine you choose as well. We've then also got the ability to adjust the model orientation. So obviously when we're modeling our file, we're modeling with a certain orientation. Sometimes you want to be machining from a different orientation. So we've got the ability in here to change that around. I'll show you that in this process as well, but we will change it in later ones. You can see at the moment, we've got the correct alignment for this particular part. We've got our Z pointing up, which is the direction we're going to want to machine from. If we wanted to, we could come in and choose or select the Z axis or plane, as well as the X axis. So if I choose that I want to select the Z axis or plane and X axis, I can essentially come in and choose either a plane, so any face, any plane that exists inside of the model. You can use your origin planes if you wanted to. You can use your origin axes if you wanted to, or you can choose an axis or a plane inside of the model itself. So we can come in and choose. If we're choosing a plane, it will create the axes normal to that plane. So just for the sake of this one, I'm going to choose this front face of the part over here. And you'll see my Z axis is now perpendicular to that face. It's normal to that face rather. If we had to choose instead a axis, if I choose that again and choose the edge of that face, it will then align my Z axis to that edge. And that's the same for any of these. So if you're wanting to choose an axis, it will align it to that axis. If you choose a face, it will make it normal to the face. In this case, as I said at the beginning, the model orientation in this model is correct. So I'm just going to go back to the normal model orientation, and you can see how it reverts back to that. So this model was created with the correct orientation. We don't have to do anything with regards to that. You can also choose an origin point inside of the WCS section, and we can choose whether it uses the stock for our origin point, whether it uses the model for the origin point. Otherwise, we can select a point or select the model's origin, and we can choose from there. So if we choose model origin, it'll just take it to wherever the origin point of the entire model is. If we wanted to choose instead that we want to choose and select a point to be the origin, we can come in and choose any point on our model, and it'll use that as the origin. Otherwise, which is probably the most common, is to use the stock box point. Model box point and stock box point work the same, except stock takes into consideration the extent of the stock. Model takes into consideration just the model without the stock. Once you choose stock box point, we can then choose one of 9 points on a face. So we can choose either the center point or the middle of any of the edges or any of the corners. So whether that's the top face, side face, front face, back face, we've got the ability to pick, as you can see in here, any one of those 9 points on a face. And we can just choose that as our origin point. And as soon as we're happy with our origin point, we can then proceed further. So the next section is the model itself. And from here, we can choose what we're actually going to be machining. If this is especially important in assembly environments, like you can see in this one. We're currently in, not necessarily an assembly part, but we've got multiple bodies inside of this part. And we want to specify which bodies we want to actually machine inside of the setup. So we want to choose just the single body over here. If I deselect that, you'll notice that the stock pretty much goes around the entire body. If I just select a single part, in here, you can see the stock, which is that yellow box, moves to the positioning of that. So essentially, we're telling it we only want to machine that body. Everything else needs to be pretty much ignored from there. If we did want to, in this case, we do add a fixture to keep in the simulation environment to ensure that we're detecting collisions with the fixtures. We can toggle on the ability to add fixtures in here, and we can come in and select either the fixtures on their own or fixture attachments. So we can come in and add 2 levels to that. So we've got immediate fixtures and fixture attachments that we can add in as well. So that's the setup tab. We've also got 2 other tabs. We've got the stock tab, which will drive everything to do with the stock itself. So we've got the ability to choose, I think it's 3 or 4 various types of stock. We've got fixed size and relative sized boxes, cylinders, and tubes. So the difference between fixed size and relative size is fixed size, we define the exact size of the box. The relative size is when we define the extent of the stock beyond the model that we've chosen. So those are the two main options that we've got available to us. And then the shape is obviously either a box, a cylinder, or a tube. Simple as that. So those 6 options are just variations of the same setup, essentially. We've also got the ability to pick from solid. So if we had a specified stock piece that we were using and wanted to take that into consideration during the machining process, we can also use from solid. So that's a really nice one to be able to bring in. If you know the exact size of your stock, either it's a standard one or you're working from previous setup, we've got the ability to bring in a solid from a previous setup. In this case, I've already got this all pre-configured because I've got this in a vise and I want it nice and snug inside there. So I've got this pre-configured, but you can play around with the width, depth, and height of the model essentially from there. One point as well is if we're using a fixed size box, you'll notice that it gives us our model dimensions. If we're using relative size box, it'll give us the stock dimensions at the bottom, just so we've got reference of what the difference is between the two. The last tab is the post-process. This is where we can come in and give it a program number and any program comments that we want when we save this out in post-process. We've also got the ability to set a WCS offset. If you have got multiple setups inside, you've got the ability to toggle multiple WCSs on, and you can put multiple setups inside of one configuration, and you can set your different starting points and origins from there. Cool. Once we're happy with that, we can just hit OK, and that's now created this setup for us. All that we need to do now is the big work of actually assigning different strategies to our component. So the first thing we would usually want to do is obviously make sure that the stock that we've put in is nice and flat. And the first tool or the first strategy we want to use for that is the facing operation. So what you'll notice is inside of the Cam tab, we had the job panel available to us where we set up the setup. We've then also got a 2D milling panel, and this is with all of the 2D milling strategies that we can use. And just next to that is a 3D milling strategy. We'll have a proper look at the differences between the two a little later on. But essentially what you want to know is within 2D milling, we give it a 2D input, and it essentially follows that 2D input. That doesn't necessarily have to be what is modeled. Essentially, all we're doing is telling it we want this profile and we want to do A, B, or C with that particular profile. However, with 3D milling, we've got the ability to tell Inventor, this is the model that we're using, and we want to use this strategy for that model. It takes into consideration the entire 3D model and will automatically work out its levels and its extent from that. So those are the main two differences between the two strategies. The one, we tell it exactly where we want to machine. The other one, we tell it this is what we want to machine, and we give it a strategy to attack that with. And you'll see this in action as we go through. So first operation, we want to have a 2D face. Essentially, once we start up our strategies, we've got a new dialog box that pops up with the operation type inside of that. So you can see we've got the name face, and it's called face 1. This is the first facing operation in the setup. The first tab we have now available inside of this window is the tool tab. This is where we select the tool that we want to use. So if I go into tool over here, this will take me now into the tool library. And from here, I can choose the various tools that I want to use inside of my configuration. This file already has some inside of it. So you can see we've got a 1/4 inch flat that we can essentially pick. Otherwise, we also have the Inventor tool library that we can choose from. This is customizable. We can create our own tools from here. I won't get into that today, but you've got the ability to create your own tools or import your own tools as well if you wanted to. But there is a really nice sample library in there that you can choose from, and you can make tweaks to the existing tools from inside here. Right at the bottom, we've got turning, we've got tutorial inch and tutorial metric, which are probably the three I use the most when giving demonstrations like this. However, as I said, this one already has them in. So I'm just going to choose my 1/4 inch flat, the number 1 tool from in there, and just select that. That now adds this tool into this configuration for me, and it gives me a preview of the tool itself as well. I can come in to the bottom section for the feeds and speeds, and I can set various speeds and feed rates for this particular job. So I can come in and change the spindle speed, surface speed, ramp speed, cutting feed rate, feed per tooth, as well as lead in, lead out, ramp, and so forth. Once I'm happy with that, one other option we've got as well is the coolant type. So this can take into consideration if your machine supports it, the different coolant types that are available to you. So we've got disabled, we've got flood, mist, through, tool, air, and you can see the rest of them on screen there. The next tab we want to go through is the geometry selection. So this is when we choose the 2D shape that we want Inventor to take consideration of when creating this tool path. In this case, we're going to leave it as default. It automatically picks up the stock contours, and because we're wanting to face the entire stock, we're going to leave it as that because that's exactly what we wanted from there. We then go over to the heights tab, and this essentially sets everything to do with where the entire depths of our operation. So we can come in and choose from the bottom. We generally start from the bottom with the height. So we choose the bottom height, which will, for a facing operation, automatically choose the model top, because we want to go all the way down to the top level of our model for this particular one. If I view this from the side, you can see all of the layers essentially from there. Once we set our bottom height, everything starts to drive essentially from that. So you'll see that our top height is currently set to the stock top, which again is correct. We wanted to start machining from the top of our stock all the way down to the top of our model. So we want to machine out everything in between there. We've also then got a feed height, which is referencing the top height. So whatever we set our top height to, our feed height is going to be X amount above that. We've then got a retract height, which is also set to stock height, and also X amount from the stock height, or stock top rather. And then we've got our clearance height, which is set to the retract height plus X. Again, X, the retract height, and it's offset by X amount. So we can come in here, we can drive the offset if we wanted to, and we could also choose a different reference point for each one of those heights. So if we instead wanted to choose the clearance height to be from the model top, if we knew that the final finish model height was what we wanted to drive it from, we've got the ability to choose from model top, and then we can choose an offset from there. And it's the same for all of the other ones. We've got the ability to choose origin, a selected contour, stock bottom, stock top, and a few other options, as you can see on screen. And also we've got the ability to choose a selection. So if we wanted to set it based on a certain height, we can come in, choose the selection, and then again, either offset that or set the offset to 0, and we'll be at that particular height. I'm going to leave this all as default just to show you how quick it is to be able to add this facing operation in. As you can see from this configuration, the only thing I've really changed on this one so far is the tool selection. I've told it which tool to use. It's automatically picked up the extents that it's going to machine. It's already picked up automatically the heights that we wanted to machine. I'm also not going to make any changes in the passes tab, but we've also got the ability to adjust the setup of the passes. So as it makes various passes over the part, we can come in and choose different configurations for that in here. So by default, it will go along the x-axis for our facing operation. We can also change in here a different pass reference point. So if we wanted to go vertically, I say vertically, along the y-axis. Otherwise, we can also change the direction. So this will automatically set from the x, If we wanted it to go at 45 degrees, the passing direction will be at 45 degrees along the entire face. There are a few other options that we've got, including the step over. One thing to note about the step over is it will always pick up the radius of your part or the diameter of your tool and allow a little bit of overstep so that it passes over the same area twice, just to make sure that there aren't any cusps left behind. But generally, it's being driven by the diameter of your tool as well. Other than that, we're happy with everything else. We'll have a look at linking in a little bit, but just for the sake of time, I'm just going to run through this very quickly. So I'm going to hit OK on here. And you can see it's automatically created that and generated our toolpath for us. The next thing we want to do is we also want to ensure that we're tracing along the outside of our part to get it down to the final level. And to do that, we can use a 2D contour. Now this one takes whatever 2D profile we choose, again, 2D strategy, and essentially goes down in the Z in multiple steps until it reaches the bottom height. And we can tell it how many steps it needs to go. But again, we're only giving it a 2D profile to follow along with. In this case, I'm going to again use the 1/4 inch flat. Probably not the right tool to be using for this one, but I just want to show you that it does pick up the last tool that you used as well. So you can continually keep adding tool paths in, and it will keep using the same tool until you tell it to use a different tool. Just another way of mitigating the need to keep making different selections. In this case, we want to choose different geometry. Again, this is a different strategy that we're going to be using. So we want to choose the top edge of this particular component. We could choose the bottom edge, but you can see that bottom edge is going to go right through the part. So I'm going to choose the top edge. I'm just going to choose that edge over there just to make sure it's going on the right side. And then you'll notice that it now gives us a little arrow indicating which side of the line of the profile it's going to be machining. If I wanted it to machine on the inside, I could flip this around and you can see that the red arrow is on the inside. I'm going to keep it on the outside and leave everything else as default. I'm then going to go into my heights tab, and you'll notice that the bottom height is chosen as the selected contour. So the bottom height at the moment is going to be that point that I chose, which is over there. And I know that that's not correct because I want it to go all the way to the bottom of the part. I'm going to hit this little drop down over here and choose selection. I could in fact just choose model bottom as well. And you should see, we're not really going to see it as well. That's gone all the way down there. We don't want model bottom. We want selection instead. So I'm going to choose selection. And for my selection, I'm just going to choose that bottom edge over there. And you can see now our bottom height goes right down to that point. If we wanted a little bit of an extension below that, we want to make sure that our contour goes right through the part. We could add a little bit of an extension to here. So I can go minus 0.1 inches. And that should take us just below there. Just want to make sure it's not cutting into anything. Doesn't look like it should be cutting into anything. So that's perfect right over there. One other really handy feature that I didn't show inside of the geometry tab is the ability to add tabs into this operation as well. And essentially what the tabs will do is it'll as it goes down for that final part right at the bottom height, it'll lift up at certain points and drop back down to ensure that there are little tabs left around the edge, just to keep your part in place before you machine and clean out the rest of the part so that it stays where you need it to be. So we've got the ability to add tabs in. We can either add rectangular or triangular tabs, and we can either tell it to, or we can give it a width and a height as well. We can either tell it to go at a certain distance around the edge, or we can tell it to go at certain points around the edge. So if I knew that I wanted a tab there, I wanted a tab there, there, and there, it's going to add those tabs right at the bottom for me, and essentially allow me to keep those in place as and when I need them. Maybe one more there, and one there, and there. And once we're happy with that, we can essentially continue from there. We've set the heights. The tabs will always be driven by the heights. And then the passes we're going to leave as we need to. I don't think there's anything we need to adjust in this one. Again, just showing you how quick and easy it is to get these configured for us. If we wanted to, there was something in the passes. If we wanted to add multiple depths, we've got the ability to put that in. So instead of it going all the way down to the final depth at once, we can have it go down in multiple depths to ensure that we've got less strain on the tool itself. So we can come in and tell it that we want a finishing step down of 0.1 inches. It's going to let me, it's the number of inches, sorry, one finishing step down. And then the maximum roughing step down we can set, so the maximum amount it's allowed to go down at a time. And then we've also got a finishing step down, so it'll leave 0.008 inches at the end. Go with the second last pass, and then go with a final finishing pass at the final end layer. Once you're happy with that, again, hit OK, and then that will create this for us. Probably got a few too many steps. We could reduce that number or increase the maximum step down, but you can see we've got those over there, and it's added in those tabs for us. So now when we were to machine around this, it'll leave a bit of stock over there that we can use as our tabs to finish off the part. The next strategy we can come in and use, we've got two that are very similar in what they do, but they do it in slightly different ways. So we've got, if we're wanting to clear out areas very quickly, we've got our roughing strategies of 2D adaptive and 2D pocket. Now, 2D adaptive will ensure that you've always got a steady load on the tool that you're using to machine. So it will always make sure that no matter where it's going, it's giving a fine and even step over all the way around your part to make sure that it's never taking in too much stock at once. Whereas 2D pocket will essentially take the perimeter of your pocket that you've chosen and slowly create offsets from the outside in, even offsets from the outside in. So it's two very slight different strategies involved with that, but two very different reasons for that. So both of them are really good for roughing, and depending on the tool that you're using, if you are using a slightly softer tool, you probably want to use the 2D adaptive. It's going to be a lot kinder on your tool and ensure a longer life on that. If you're machining softer materials, 2D pocket works just as well. It's going to be a little bit quicker most of the time. But yeah, the two different strategies we've got available to us. For this particular one, I'm just going to use 2D adaptive. The selection process is much the same. It's just a few settings that are different between the two. So for this one, all we need to do is select the pocket that we want to clear out. So in this case, I want to select all three of these pockets, 1, 2, and 3. And you can see we've got our pocket selection over there. If we wanted to use stock contours, we could use stock contours, a few other options that we've got available to us there. And the really nice thing about the adaptive clearing or the roughing operation strategies that we've got available to us is we don't actually have to worry too much about the heights, because we've chosen the bottom height of a particular pocket. It will automatically know that that's the height that it needs to go to. So you'll notice that in selected contours over here, or bottom height rather, we've chosen selected contours. We've chosen those 3 separate heights, 2 of them the same height and 1 slightly above. You'll see if we had to, it's not as clear in this model, but if you had to have a look at the height of those 2 lower pockets, they'd go right through this part. So if we had to choose a single height, when we machine this pocket in the middle, it would go all the way through the part because of the cavity underneath it. In this case, we've chosen the bottom height of all 3 pockets, and it'll only go down to that bottom height automatically for us. If you have a look at our passes tab, this is where we have a few differences in adaptive clearing and 2D pocket. We've got the ability in here to set an optimal load for our adaptive clearing. So this is the amount of load that the tool will always have on it. And this is essentially the amount of material it's taking off on the radius each time. So this is what we can set inside here. And generally speaking, this will only go in one direction around. So whether you're choosing conventional machining or climb, it'll essentially go in one direction the whole time. Otherwise, we've got the ability to toggle on both ways, and that will then combine conventional and climbing. Other than that, we can set everything again as default. What we are going to do for this particular one is uncheck stock to leave. Generally, you would probably, when you are using a roughing operation, you would want to leave a bit of stock because this is going in very quickly. It's not going to be nice and smooth. It's going to be a really rough finish. So we would leave stock to leave on. We can set how much radial and how much axial stock we want to leave behind. In this case, I'm going to uncheck that, but that is something you would usually do, and you'd go in with a final finishing pass later on. In this case, I'm going to leave this as my finishing pass, just for this demonstration, and because I'm taking a lot longer to run through this as I would expect to. So yeah, we're going to rush through this. The next tab over is the linking tab, and this will drive how the different passes link together. So when you're going from one pocket into another, how you link those together. So anything that drives those particular settings will be set inside of the final linking tab, based on the retraction policy, whether it does a full retract, whether it does a minimum retract, and some of the other ones will have a third option as well, which should be the shortest path. So it takes you right from the end of the one to the beginning of the other. We've got high feed rate mode, whether we want to reserve it or preserve rapid movement inside them. We can also choose how long we stay down for, so that the minimum amount of time that we spend on the bottom of our part. Otherwise, it'll automatically do a little bit of a jump. It'll retract ever so slightly, move over to the next point and down, and then machine further. Sometimes you just want the tool to just stay down and avoid the retract and entry points each time. So we've got the ability to set that from inside them, as well as being able to set the ramping options that we've got available to us. So we can come in and also choose how it ramps into our pockets, whether we want to use a helix, whether we want to use plunge, whether we want to use a pre-drill. We've got the ability to set those inside here. Again, once we're happy with that, we can just hit OK. And you can see it's now doing the little helix into the pockets and doing an adaptive clearing right from the middle of that part and working its way out and around, ensuring that there's always that optimal load on the tool itself. And it does that for all three of those pockets. And if we have a look at it from the side, you'll see that the heights of the two pockets on the side are lower than the pocket in the middle. So it's automatically picked that bottom height for us. The last one I want to show you very quickly, because we won't bring it up on the next one, is the drilling operations. So very similar process really in getting these configured. We've got a drilling panel available to us where we can essentially choose this option. Again, we need to choose a tool that we want to use for drilling. I believe they should have a number 4 tool over here, which is the one that we're going to be using in this case. But again, we've got a library that has a whole lot of drills available to us, drill bits. Otherwise, you could always create your own one as well, using the new mill tool, new mill holder, or new turning tool options at the bottom. We can create new tools for our entire library. In this case, it would be a new mill tool. If I select this very quickly, we should see it somewhere. It's not showing up. Interesting. But essentially what we need to do is now choose the holes that we want to drill. And by choosing the hole, it will automatically pick up the extent of that hole as well. So the surface that we've chosen, it'll know what the top of the hole is and what the bottom of the hole is, and choose that entire depth for us. What we can also do in here is we can choose any other hole in this part that has the same diameter. If I check that, you should see it pick all 4 holes that are in this particular part. We could, if we wanted to, filter that down and choose only the ones with the same depth, hole depth, only the ones with the same Z top height. Or we could choose a containment boundary and create a boundary around certain holes and say we only want to machine the holes that are inside there. In this case, I wanted to machine all 4 of those. We can then choose the order of these and yeah, essentially mitigate any other holes being selected as well. And if we wanted a particular order, we've got the ability to add that in as well. In the heights tab, again, it's automatically chosen the bottom of that. If we want the drill tip to go through the bottom height, we have got a checkbox there for that. So we can go through the bottom height and essentially run from there. And then in our cycle tab, we've got various drilling cycles that we can choose from, whether we're wanting to do counter boring, whether we wanted to do chip breaking. We've also got the ability to do tapping from inside here. So if we were wanting to tap the hole, we've got a tapping cycle that we can choose and add that in from inside here. Otherwise, there's also a custom one as well. But once we're happy with that, we can just hit OK, and that will now add that in for us. Once we're happy with the simulation itself, we've got the ability, or once we're happy with the configuration itself of all of the operations, we've got the ability to simulate the entire setup. So if I go into my simulate tab over here, you'll see we've got the ability to run through this entire operation. This is just the drilling operation that it's going to be showing us over here because I only had the drilling operation selected. But if I close this off in the window over here and choose the top setup, so this will choose everything that's inside of that particular setup, hit simulate, it'll bring in all of the toolpaths from all 4 operations. And I've now got the ability to come in and play that all the way through. So there's the facing operation. We've also got a little later the 2D contour. You can see the timeline down at the bottom. We've also got the 2D adaptive, as well as finally the drilling operation. If we wanted to, we could toggle the visibility of the tool path. So if we didn't want to see the tool path, we can toggle the visibility of the tool. So all we'll see now is the point as it goes around the machine. And we've got the ability to toggle the visibility of the stock as well. So as the stock goes around over there, we've got the ability to see exactly, or as the tool goes around, we've got the ability to see how it interacts with the stock. If I speed this up ever so slightly, you'll see that the stock will have different colorization options. We've got the ability to choose either by operation. So each individual operation will show up with a different color on the stock. We can also choose by tool. In this case, we use the same tool for the facing and the contour, so we're not going to really see anything. If I go over here into the pocket or the adaptive, again, it's the same tool, so it's not really going to show us anything. However, if I had to change this to operation, you can see that each individual operation gives a different color. One other thing to point out quickly while we're here is the tabs that are left behind. So you can see where we've added those tabs, and it's left that behind as part of the machining setup. We've also got the ability to control the speed of the simulation, so we can adjust how fast or slow this simulation goes. We can skip either individual moves, individual operations with the next button over here, or skip right to the end of the entire simulation, and then the buttons on the other side do the opposite. So right to the beginning, rather a few steps behind, a few operations behind, and then right to the beginning. So we've got the ability to play or skip parts, segments, or operations. Once we're happy with it, we can essentially just close this window again, and we go back into our part from within there. So I want to show you very quickly, apologies, I am going over with this one, but I think it's very important to show this as well, is the 3D tools that are available to us. So what you'll notice is we've got our 2D adaptive and 2D contour. We've also got a 3D adaptive and a 3D contour, as well as a pocket clearing. So we've got the adaptive, pocket, and clearing on both the 2D and the 3D side of things. And again, as I said right at the beginning, they take into consideration the two different strategies, really. One only takes into consideration 2D input we give it. On the 2D side, the 3D takes into consideration the entire 3D model. So if I wanted to quickly create a 3D setup over here, I don't have to necessarily create my setup first. I can go straight in with an operation. So in this case, I'm going to use 3D adaptive. It's automatically going to guess the origin point, the orientation, all of that for me in the setup. If you wanted to choose that, again, we created a setup at the beginning. I'm just going to come in here and choose a tool. I'm going to use the same flat tool that we used earlier. Yeah, actually, I'm going to go for 3/4 inch, a little bit bigger. And the tool orientation is incorrect. So we can change that around in the geometry tab. So in our geometry tab, if we're using 3 and 2 machining, we can change the orientation of a tool in each individual strategy, in each individual operation. By going over to the geometry tab, we've got a tool orientation button, and we can override this manually inside here. So rather than using the setup, we're going to choose our own Z axis, which is going to be aligned to that face, and hit OK on that. Without changing anything else, all I've done is chosen the tool and I've chosen the strategy. I'm going to hit OK on there, and it will go off and automatically calculate the tool paths that are required for this particular operation. You can see how it automatically clears out everything around that particular part. We could then go in, again, this is a roughing operation, so there'll be a bit of stock to leave left behind, so it's not going to go right down to the finish level. We can then go in and add some of the finishing operations inside of the 3D milling strategy. So some of those will include scallop, which will essentially take and have multiple passes with a very small offset. And these are really good for curved surfaces, so especially around the top of this particular part. We've also got spiral, which, as the name implies, it starts from a center and does a little spiral out with very small passes or offsets, essentially, on each individual pass. So it's a very small step over. I said it starts in the middle. It could start at the outside and work its way in. We've also got the ability to pick up a morphed spiral, which is almost pretty much a combination of spiral and of scallop, and essentially starts from a center point and morphs its way around the part based on the geometry of the part. This is a really nice one to show off as well. So again, I'm going to go use that same one. I'm going to actually use a smaller tool very quickly. Just this. Let's find a nice round one. Let's go into our inch sample library and find a nice small bull nose. Let's go for the 1/2 inch, actually 1/4 inch is good, and select that one. Again, changing the tool orientation, I could have done this in the setup, but I can also override it in here. I'm just going to choose that top face over there. Everything else as default. I'm going to hit OK on there, and it's going to automatically calculate that for me. You can see how it starts right in the center and works its way out, spiraling out. If I view this from the top, it looks pretty straightforward, but it's automatically curved those as it goes down in the different heights that it needs from there, essentially. We've got a few other strategies that we can use inside here. We've got the horizontal strategy, which I can't see without my glasses at the moment. There we go, which will essentially only target horizontal faces. So anything that's flat, it'll automatically come in and flatten those out for us. We've also got contour, which works similar to our 2D contour, where it goes around an edge. And this is great for any edges or any faces that have a bit of an angle to them. It'll automatically sweep its way down a particular edge. And a few other strategies that we essentially got available to us, but they all follow, as you can see, a similar process. So we select the operation that we want to use. We then choose the tool that we want, set its feeds and speeds, set the geometry we want to use if we want to use that. Again, 3D strategies, you can almost just push it straight in unless you want to limit the area that you want to machine in. We can set the heights. Again, optional with 3D milling. And then we can set the passes options, and each individual strategy will have its own passes options that are tailored to that particular operation. And then linking is the final one, where again, we can choose the retraction policies, we can choose feed rates, we can choose lead ins and lead outs, and essentially tweak those based on each of those individual options. So yeah, I hope that's been beneficial to you. Sorry again that I've run over time, but yeah, really nice. Just wanted to get nice and detailed on some of those things that a lot of people do find confusing, and hope that's managed to clear that up and given you the confidence to give this a try. It's a really, really handy piece of software. So yeah, if you have any comments, anything you'd like us to have a look at in a bit more detail, do feel free to drop us a comment. Like the video. There are a lot of other videos explaining different CAM strategies, anything that's new inside of Inventor or Fusion for that matter. And we've got the ability to obviously add more on there. So again, if there's anything you'd like to see in particular, give us a shout. Otherwise, thank you very much for your time. Have a great day further.